Hello, in this video we'll be talking about how to sketch cubics. So if we're given a rule, how can we actually put this onto a graph? So just like with the previous topics, linear and quadratics, we do need to find all of the intercepts as they're crucial points to sketch. Now we won't talk about stationary points, turning points. We will talk about a little bit about point of inflection, but we won't have to label them just yet, not until we reach calculus. Now, over here, to sketch the intercepts, generally the y-intercept is quite easy to do. All we need to do is sub in x equal to 0. So let's have a shot. If x is equal to 0 for the first example here, then f of 0 is going to equal to just 6 over here. This means your y-intercept is going to be at 0, 6. Alright, x-intercept, this is where things get a little bit messy. Okay, so I know x minus 1 is a factor. So this means x minus 1, if it's linear, it needs to be multiplied by something with an order of 2 to get to a cubic, which has a polynomial order of 3. So this means it must be multiplied by a quadratic. To find out what that quadratic is, we can do a little bit of long division. So we're going to be dividing by x minus 1, and we're dividing x cubed minus 7x plus 6. So what this is trying to achieve is to see what can multiply with x minus 1 to get your cubic expression. Okay, sorry, I'm going to rewrite this out. So when you do a long division, you should have a placeholder for each order. So you've got x cubed here. What comes next should be x squared, but we don't have any, so I'm still going to put 0x squared there. Just x by itself is next, so minus 7x plus 6, which is our constant. So when you divide, what we do is we say that how many times does the coefficient of x over here go into the coefficient of x cubed here? Well, they're both 1, so this means that it only goes in once. So on the right, we say there's 1x squared. Okay, and from there, we have x minus 1 here. The coefficient of our second term here is negative 1. So this means we have negative 1x squared. Draw a line, and we want to subtract the top one from the bottom. Sorry, other way around. We're subtracting negative x squared away from the top. So 0 minus negative 1 gives you x squared. And we're going to be dragging the minus 7x here down over here. Alright. So how many times does the coefficient of x squared here go into here? Just once. Just x squared minus x. So it's minus x over here because it's just minus 1 over here. Negative 1 times 1 still gives you negative 1. Okay? And since it only goes into x squared once, it says plus 1x over here. Okay, so we've got to do our subtraction again to get to the next process. So negative 7x minus negative x gives us negative 6x. And so what happens over here is that we're going to drag this 6 down over here. Plus 6. And we need to have these two numbers be the same. So we need our coefficient to be negative 6 now. So this means that we're going to be multiplying this by negative 6, or this whole expression over here. So negative 6 times x minus 1, this means that you're going to have positive 6 instead, because you're going to have negative 1 multiplied by negative 6. And you should see that these two are the same on the last step. If x minus 1 really is a factor, there shouldn't be any remainder down over here. And so if your coefficient is negative 6 over here, negative 6 up here, because that's how many times this factor, that's how many times x minus 1 goes into this part over here. Okay, so now that that's done, we know that's our quadratic factor. So we can safely say, just going to draw a diagonal line here, f of x can be factorized to x minus 1 times x squared plus x minus 6. So what we've got to do to get more linear factors is factorize our quadratic as well. A few ways to do it. Easiest way is probably cross method if you have some simple integers to work with. So in this case over here, x minus 1. Now we've got to multiply to get negative 6 and add up to positive 1. So we get x plus 3 and x minus 2. Okay, so you can easily see the x-intercepts here, where we're going to have 1 at x equals to 1, x equals to negative 3, and x equals to 2. So we can plot these points down on our graph over here. So remember, the key features we want to label in this topic are the intercepts. So let's try that out. So we can have 1 at there's 1 at 1, 0, 2, 0, let's go out here, negative 3, 0. We also have our y-intercept here, 0, 6. Doesn't have to be to scale, remember, it's just about labeling the key features. And of course, drawing the correct shape. So from here, we know this is a positive cubic because the coefficient of x cubed over here is positive. So we must start from the bottom left. Go through our y-intercept, pass through 1, 0, and go back up through 2, 0. So we end up back at the top. And that would be our graph f of x. Talk more about these turning points when we get to a later topic. Okay, so here's a graph, or here's a rule, I should say. And it's in a very convenient form. So it's in the SPOI form, stationary point of inflection. What this is telling us already is that it's a SPOI at 3. Remember, we take the opposite sign here, and at negative 27. So it's been shifted to the right by 3 units and downwards by 27 units. Okay, so from here, let's have a look at x-intercepts. Actually, not x-intercepts, y-intercept first, that's a bit easier. This one may be a bit tricky. Okay, so for your y-int, over here, we know that, let's see, we need x equal to 0. So this means we're going to have negative 3 squared minus 27. We're going to get, not squared, so all these should be cubed. We're working with cubics here. We're going to have negative 3 cubed. So it's negative 27 minus 27, which should give us negative 54. So our y-intercept is at 0, negative 54. Now from here, x-intercept can be a little bit tricky. First of all, let's just recap something. Remember the difference of perfect cubes. It's actually very convenient to use whenever it's in SPOI form, whether it's a difference of perfect cubes or even the sum of cubes. Or they don't have to be perfect cubes, just cubes. So this is the difference of cubes. Over here, we know that we can follow the rule where x cubed minus a cubed is equal to x minus a, our first linear factor, multiplied by the square of the first term plus the product of the two terms, and then adding the square of the second term, where the two terms are going to be x and a. Okay, so and we can do a similar thing for this rule up here. So I'll just go in different color. So because we're pretty much moving on to a new step. So we know that the first term is x minus 3. The second term, now we need the cube of 27. Don't worry about the negative. We're really looking at difference of cubes. So we're just looking at this cube over here and this cube. And the difference is made up by the minus sign here. So the cube root of 27 is 3. So we know f of x is the first term, x minus 3, minus the second term, multiplied by the first term squared, plus, so the second term is 3, first term is x minus 3, plus 3 squared. Okay, so we're just going to do a bit of factorizing, or not factorizing, simplifying here. It's a little bit messy. So x minus 6 over here, when you expand this square, you're going to have x squared minus 6x plus 9 plus 3x minus 9 plus 9. Alright, so we need to collect log terms here. X minus 6. We're going to have one x squared term. These two over here can be collected. We have minus 3x. We've got plus 9 minus 9 plus 9. So these two can cancel out. But we still have 9 left. Alright. So you may be thinking, oh, okay, so we have one linear factor, and if it's a cubic, we should have three linear factors, right? Well, maybe. But before you even start to question if you can separate this into two linear factors, how about we look at the general shape? So we know so far that there's going to be a y-intercept at 0, negative 54. We also know that there's this point. So it's going to do some funny business here where there's a stationary point of reflection. And from what we've factorized so far, we also know that there's an intercept at 6, 0. So what does that all mean? Well, this is a positive cubic because our x cubed term is going to be having a positive coefficient. So it's going to loop like this. So it's coming through the x-axis over here. Is it possible for it to cut through the x-axis anywhere else? No, probably not. And you can also go through the algebra proof why this can't factorize. And you can do this by saying that the discriminant of this quadratic expression in the bracket is less than 0. So you can work that out in your own time. It should be less than 0. And the visual way also confirms that as well. Okay. So the crucial thing here, when you're drawing this graph, is that, remember, this is a stationary point of reflection. What does it mean when a point has a stationary characteristic? It means that the gradient is 0. So when you draw the stationary point of reflection, it's not only inflecting, there's also, you can draw a tangent of, well, a slope of 0 there, so that so the tangent over here should be having a tangent of 0. Alright, I think we'll do one more example. Okay. We have negative x cubed minus 5x squared minus 3x plus 9. And we're also given that x minus 1 is a factor. Alright, so from here, we have to go through the same process of long division just to see what this can be simplified down to. Okay, so x minus 1, negative x cubed minus 5x squared minus 3x plus 9. Okay, so going from here, we need to slot the x minus 1 here, or the coefficients of x minus 1. Okay, but how can x minus 1 turn into negative? Have negative coefficient here. This is positive 1. It needs to multiply by negative 1. So this means that the negative 1 over here also gets multiplied by negative 1. So you get positive 1 now. So it's positive x squared. And so since we multiply by negative 1, we're going to have a negative 1 coefficient for our first term. So that's the first division process. Subtract now. So negative 5 minus 1 minus 6 x squared. How do we get from positive 1 to negative 6? Multiplied by negative 6. So the negative 1 turns into positive 6. And of course, this 3 gets dragged down here. Since we multiplied by negative 6, we're going to have negative 6x over here. Negative 3 minus 6 is negative 9x. So actually, I haven't been doing this as often as I should, but as soon as you see there's a negative 9 here, and you need to multiply what you're dividing by negative 9, and slot this up here straight away. Okay. So I'm dragging this 9 down here. And when you multiply that by negative 9, you should end up with this as well. So it matches up. Alright. So we know that f of x factorizes to x minus 1. Negative x squared minus 6x minus 9. Right, we see there's a lot of negatives here. Let's take out a factor of negative 1 out, just to make our life simpler. So I'll just put it at the front here. Remember, multiplication is non-commutative, so it is commutative, so we can multiply in any order. Alright. Okay, so since we got up to this step over here, now if you look over here, you can see that it's very easy to factorize this quadratic. We can just use what is it called? Expansion of a square, a perfect square. So if you have a plus b all squared, a squared plus 2ab plus b squared. So really, f of x over here is equal to negative x minus 1. And looking at over here, our first term is x. X times what? Well, oh sorry, x plus what? Well, it's a square of 3 to get 9. And if you multiply these two together and double it, you get 6x. So this works out. Square. Alright. So it's pretty easy to see the y-intercept here. So the x-intercept, there's 1 at x equals to 1. Do this in green. And x equals to negative 3. Now what I want to do here is, if I identify at x equals to -3, and I see a square here. Note to yourself that this is a parabolic kind of set. It touches the x-axis. So just write a 2 with a circle there, saying that there's an order of 2 there. And if I draw an axis, okay, so before we start sketching, let's find the y-ends first. Let's forgot about that. So for your y-ends, very simple stuff. You just let your x equals 0 and find the function value. So that would be 9. 0, 1. Okay, let's have a shot at this. So there's 1 over here at x equals to -3. One over here at 1, 0, and up to what? 0, 9 for our y-intercept. And if we sketch through here, we know there has to be a touch over here, a parabolic kind of vector intercept. And it's going to cut through here and cut through here. Remember that this is a negative cubic. So what does this mean? We start at the top and end up at the bottom. So I'm going to cut the x-axis, go through our y-intercept, and cut through 1, 0. Just redraw this a little bit. This shouldn't be diverging outward. This is our function f of x.